we decided 3 years ago almost to develop a DADA2 animal model, and we pick up the zebrafish because zebrafish is really a powerful model organism for studying human diseases. And this is because of its genetic, developmental, and also practical advantages. So, first of all, zebrafish share a high genetic similarity with humans, with approximately roughly 70% of human gene that are conserved in zebrafish. And in particular, we identify this gene known as CECR1B, which conserve quite a good sequence with human ADA2. Then, the zebrafish is really an animal model, so it's transparent. The embryos are transparent, so we can really follow live the movement of cells, the development of organs. So really, it helps really facilitate the real-time visualization of what's going on there. And then it also, finally, because it's very easy to genetically manipulate. So what we did is to remove the ADA2 expression in zebrafish embryo genetically. And then we investigated the pathological mechanism and also tested treatment efficacy. The first important finding is that in the DADA2 zebrafish recapitulates the ADA2 deficiency in terms of defective hematological development, vascular and systemic inflammation. So what we identify in this zebrafish is that DADA2 zebrafish have less neutrophils, so they are neutropenic, and there is also a significant increase of TNF and also other pro-inflammatory cytokines. And importantly, there is also a significant reduction in hematopoietic stem cells. And we identify the mechanism, which is due to a defective abortive budding of the very early progenitors that reside in the endothelial cell layer. So we see that this layer, which then give rise to hematopoietic stem cell, has a reduced vascular network. So there is a defective budding, release, maturation, and budding and release of hematopoietic stem cell. We genetically downregulated the expression of TNF-alpha. We know that in patients, TNF-alpha therapy is given to reduce inflammation. And what we find out is that in DADA2 zebrafish in which we downregulated the TNF-alpha expression, there is a significant improvement in hematopoietic stem cell counts, which leads to also complete neutrophil recovery. So it seems that indeed TNF-alpha inflammation is the culprit of the hematopoietic defects, at least in zebrafish. Then, since we know very much that it's important also to test the possibility of an enzyme replacement therapy in this patient, we supplemented human ADA2, recombinant ADA2 in DADA2 zebrafish, and the hematopoiesis improved. We observed restoration of proliferation of hematopoietic stem cell, which then give rise to a normal and improved neutrophil counts. The first implication, although maybe we cannot completely translate the zebrafish to human, but definitely our data suggest that ADA2 deficiency affect hematopoiesis early before cells commit to become hematopoietic stem cells. We don't know if this is going on also in patients, because during development, we think that ADA2 from the mom can pass to the baby. So during the developmental phase, at least the maternal ADA2, I think, support hematopoiesis. But then after birth, probably the fact that inflammation is there, progressively this might affect the maintenance of stem cell, which receive continuous inflammatory triggers by TNF and other means, which make them proliferating and differentiating. And over time, this may lead to an exhaustion and deprivation of HSC. The other impact, of course, is that potentially the loss of hematopoietic stem cells can be corrected by ADA2 enzyme replacement therapy. And these data support very much the development of pegylated ADA2. And finally, I think that using anti-TNF is important in patients, is important because it not only reduces vascular and also systemic inflammation, but it might help also maintaining hematopoietic stem cells, preventing somehow their deterioration. We need to determine in patients whether long-term treatment with anti-TNF has an impact on bone marrow. And future study probably will tell us more about that. Maybe anti-TNF is helpful in this regard, maybe in patients with mild symptoms, when those have still a quite good hematopoietic system. I doubt that it may work in severe cases with severe hematological symptoms who require bone marrow transplantation.